Hello everyone. Today I am going to discuss the fifth problem of AtCoder beginner contest 365, which is XOR sigma problem. So what is the problem? We are given an integer array A of length n. We have to find the value of the following expression. So what is the following expression? Following expression is nothing but the sum of XOR of every subarray of length greater than 1. So that is the problem statement. Okay. So let's say we are given some subarray A1, A2, A3. Now we have to find the sum of all XOR of all the subarrays of length greater than equals to 2. So the formula will be, resultant answer will be A1 XOR A2 plus A2 XOR A3 and A1 XOR A2 XOR A3. Okay, that will be our desired answer. Okay, so let's take one example. We will understand it better. So the first example itself is of length 3, 1, 3, 2. Okay, so let's take A1, A2, A3 is nothing but 1, 3, 2. So it will be 1 XOR 3 plus 3 XOR 2 plus 1 XOR 2 XOR 3, right? 1 XOR 2 XOR 3. Now what will be the value of 1 XOR 3? 1 XOR 3 is nothing but 2. 3 XOR 2 is nothing but 1, and 1 XOR 2 XOR 3 is nothing but 0. So what happens in XOR? If let's say let's consider bitwise operation. Let's say one bit, the 0th bit is set in even number of places. If 0th bit is set at even number of places, then the bit will be unset in the XOR. Okay. So here when we are taking 1 XOR 3, it is nothing but 0, 1. If we represent 1 as binary format, it will be 0, 1, and if we represent 3 in binary format, it will be 1, 1. Now for the 0th bit is set in both places, both in 1 and 3. So it is set in even places. So in the resultant, this bit will be unset, so it will be 0. But here the first bit is only set in one place, so it is set in odd number of places. So we can say this bit will be set in the resultant. So that's why the resultant value will be 1, 0, which is nothing but 2. I hope you get it. Now what is the brute force way to solve this problem? So let's call it brute force. So the brute force way to solve this problem is definitely will be to iterate over every subarray and find the bitwise XOR. So the overall time complexity of that operation will be order of n square, right? So we are iterating over all the values of I and j, and we are finding the XOR. But let's check the constants. The constants on n is 2 into 10 to the power 5. So that is definitely not possible. So how we can think about improving our algorithm to something better, something fast. Okay. So for that we will consider the contribution of individual bit instead of considering a number or a contribution of any index of the array. We will consider the contribution of a bit. So the total number of set bits could be AI could be at max 10 to the power 8. So the total bits in AI could be at max 30. So we have to find the contribution of each set bit, each bit from 0 to 30. Okay, I hope you get it. Now let's say we are considering some 2D array, 2D binary array. Okay, so what is the 2D binary array? So let's say this is the bit index. Let's say this is the bit index. So this is 0, 1 and 2, and this is the index. Okay, this is bit index and this is index. So this is 0, 1 and 2. Okay. Now the 0th bit is set at the first 0th index and the first index. So this will be 1, 1 and 0. The first bit is set at the second index, first index and the second index. So this will be 0, 1, 1, and the second bit is set at only the second index. So it will be 0, 1, 1, and second bit is not set anywhere, so we can only take the bit 0 and bit 1. Okay, so we have these two arrays. Okay, two binary arrays. Now we'll try to from the first array we'll try to find the contribution of the 0th bit. So whatever contribution we get, we will multiply it by 2 to the power 0, and whatever contribution we get from the second bit, the first bit will multiply it by 2 to the power 1, and we will solve the problem separately for each bit. Okay, so you can say that we are taking the array of binary array of length n, and we are passing it into some function, let's say f, let's say if, and it is taking some vector of length n, and it is giving us some value. So we are multiplying it by if. Let's say we are calculating for jth bit, so we are finding f of vj into 2 to the power j, and our answer will be nothing but summation of f of vj into 2 to the power j. Now how we are going to calculate f of vj? Let's find out that. So we have, let's say, 110. Okay, 110. Let me take one moment. Okay, so I'm back. So let's say we have something like 110. Now we'll try to find. We will have something like prefix. You can say prefix j0 and prefix j1. Okay, prefix j0 and prefix j1. What does it mean? Prefix j0 means that in the prefix how many positions that the this bit is even. Okay, and prefix j1 is means that in the prefix how many positions that this bit is odd. Okay, so here initially prefix j0 will be 0 and prefix j1 is 0. Okay, now when we are encountering one value, okay, now we will increment the value of prefix j1 by 1. Okay, now and let's say we are moving to the second position. Now say here we are encountering another one value, right? We are encountering another one value. Now the previous positions where this position was odd, it will get reversed. So initially only there is only one prefix which has odd prefix value. Now there will be one position where the this value is odd. There is an odd number of ones present, and there is one position when even number of ones are present, if we consider in this way. Okay, in this prefix in this if we take only this position, then the this position, then the number of ones are odd, and if we take the entire prefix, the number of ones are even. So our prefix j0 will be now 1, and prefix j1 will be 1 again. Now when we are at this position, this 0, then the values will remain same, but the number of position where the prefix j0 is even, prefix j is even, that is incremented by 1. So I'll jump into the code, you will understand it better. So what I am doing here, I am iterating over every value. Parent is nothing but I am taking parity, you can call it prefix also. So if the bit is set in if the j bit is set in the ith index, okay, so we are multiplying it by parity of j0 into 2 to the power j. Why? Because let's say this bit is or this one bit will set all the previous, all the even prefix ones. Okay, I think I am making it hard to understand for you. So let me run through it again. So 1 1, that is 1 0 1 0. So something like this. Okay, and we have encountered this one here. So we can say that this position, if we take only this position, this is even. Okay, if we take this position, this thing, then this will be odd number of ones are present, so we can call it odd. Now if we take this 3, again this is odd. Now if we take this 4, then this will be even number of ones present, and if we take all these values, then again this will be even. So when we are taking this one, okay, when we are getting this one, so we are making all these even ones, all these even ones, we are making them odd. Okay, we are making these events odd. Okay, that's why we are making them odds, and we have already discussed that if someone is making all of them odd, then we are only adding the contribution of 2 to the power j to the odd positions. So we will take prefix of j0 into 2 to the power j, because we have this two prefixes where they will be odd number of ones will be present. Okay, and now these events are becoming odd. Okay, so initially this is e o o e, now these are becoming o e e o o e e o and o, right? O e e o o. I hope you get it what is happening now. So that's why we are swapping parity of j0 and parity of j1, and as the last element is incrementing the value of odd parity. That's why we are incrementing the value of parity of j comma 1. Now if instead of this, let's say we are adding one more 0 to this, so let's say 0 1 0 0 1. Now the value is nothing but o e e uh, o e e o o. Now we are adding one more 0, right? We are adding one more 0. This will not change the parity of odd and even, so this will again be odd. That's why what we are doing, we are doing answer plus equals to parity of j1, the odd positions, into 2 to the power j, and here the we are incrementing the value of we are incrementing the, this will be even, right? So we are incrementing the value of even, so that's why we are doing parity of j0 plus plus. I hope you get it. I think I have made it difficult here by calling it prefix. This is not exactly prefix, you can ignore that. So we are taking uh, just remember the concept that we are taking this concept, that this will be even. If we are adding some 0, this will be even, and we are taking from backwards. Okay, so this will be even, and when we are adding 1 1, it is becoming odd. Now again we are adding 1 0, the parity is not changing, but again when we are adding 1, the parity is changing to even, and again when we are adding 0, the parity is not changing, so this will be even again. Okay, I hope you get it. I will provide the link of the code in the description box. You can check that out, and if you have any doubt in any part of the explanation, you can always ask in the comment section. Also, let me discuss about the time complexity of this. So the time complexity of this is that we are iterating over every index, and for every index we are iterating over every bit, so the overall time complexity will be order of n into 30, and the space complexity is don't have to discuss, this will be order of n plus 30. Okay, I hope you get it. If you find this video helpful, please like the video and subscribe to my channel. Thank you.